Ooh.
You know, Monday morning, we had a couple of late buses, so please retake attendance. Thank you.
Done and done. Today is the 27th. Oh, better repause this. Hold on a second. So today you begin your journey of solving quadratic equations. This will take a while. This is a big one. This occupies a good part of the rest of the year for us. Not like the entire thing, but several weeks, because the way we're going to solve them today is not the same as the way we're going to solve them next week, and that's not the same way as how we're going to solve them, after that. So we hit this a lot harder and heavier in algebra 2, but we do want to hit it in algebra 1. So what is quadratic? You guys remember that word? It's got x to the second power in it, right? And so let me just give you a side note here, and you're welcome to or not to write this part down. But everything that you've been doing up to this point in your academic career have been called linear equations. We don't generally call them that while we're doing it, or we do, and it just brushes right by. Like you just know that that's what they're called. But all the equations that you've solved so far have looked like this. And what's unique about linear equations is that you can always accomplish this task. Here it goes. You can always get x by itself. Always. Now, if I've done my job and Mr. Manlove did his job and Mrs. Eklund did her job and everyone in line to this point has done their jobs, including you, then you know how to do this. You know that you can bring the x's together on the left side, presumably, like I would add 2x to get 5x over here. And then I would add the 4 across to get 25 over here, right? You can do this, hopefully almost in your sleep by now. And then when you divide both sides by 5, look what we did. We found the solution. And remember that the solution to an equation is the number that, if you put it here where there's that little yellow arrow and here the other little yellow arrow, the equation's left side and right side would equal each other. That is the essence of solving an equation, is you find the number that makes the equation a true statement. Like in this case, if you put in 5 for x, your left side would say 15 minus 4 is 11. And then your right side would say negative 10 plus 21 is 11. And 11 does in fact equal 11. So 5 is the magic number that makes this equation work. So that's what we've been doing with you now for years, is learning how to solve equations like that. And you can always perform steps. Sometimes it's killing fractions, sometimes it's distributing, combining like terms. There's all sorts of little tricks that we've inherited or absorbed over the years. So bear that in mind, that will not be possible anymore as of today, because now we're dealing with equations that, well, you'll see, you cannot, quote, get x by itself. And it looks like this. So there's your first of about 200 quadratic equations to come. And right away, if you're paying attention, you see the issue. You say like, yeah, you're right. I cannot get x by itself because there's more than one and they're not the same type. And you know that you can't put an x squared and a minus 4x together, right? So an activity that I have performed with students in the past is to have you guys just start tinkering with this and see if through sheer will and determination can you figure out what x has to be. Because you cannot, again, quote, get x by itself. I hope you're picking up what I'm putting down there. Like, that ain't happening, right? So if you don't know how to solve a quadratic equation, you could spend a long time on this, assuming that your teacher gives you an equation that has nice solutions, right? Can anyone think of a number that might solve this equation? I mean, this is not the way we solve. I just was curious to see. You want to try 3? Sure. Like the worst that could happen. So like I feel like I use this analogy sometimes or this example, but I feel like if I took a sixth grader, a dedicated sixth grader, and said, like, I'll give you a $50 Amazon gift card. If you can solve this equation, I'll give you half an hour. I bet a dedicated sixth grader could do this, and I bet you could too. And that is exactly like Miss Roscoe said, just pick a number. And if it doesn't work, then you know that that's not the solution, right? So like if you put 3 in place of X, and again, this is not how we solve quadratic equations. I'm just showing you how bad this would suck if we didn't learn what I was about to show you. So like if I put 3 in place of X, I would get 9 here for 3 squared, minus 4 times 3 is 12. 9 minus 12 is negative 3. Negative 3 minus 12 is negative 15. Negative 15 does not equal 0. So we can definitely say 3 does not work. Bryce thinks that 6 might work. So if I put 6 here, I get 36. Nice job. Minus 4 times 6 is 24. 36 minus 24 is 12. Minus 12 is 0. Now, the thing about this, nice job, by the way, is that if you got this, if you said that X equals 6, you wouldn't get the $50 Amazon card because there's more than one solution. And that's the thing about quadratics is that they have 2 answers. And generally, we can find the first one without too much struggle. I don't know how long that took. What'd you think? A minute, maybe, for Bryce to come up with 6? Sound about right? The other answer is negative 2. And I mean, think about like how hard would that be for us to find if we were just shooting arrows in the dark? Like, where would that even come from? But if you'd like to see it work, let's just test it real quick. Let's take negative 2 and let's put it right there first. What's negative 2 squared? Definitely positive 4. And then this yellow bubble that I'm making right here, what is negative 4 times negative 2? Positive 8. And look at that, 4 plus 8 is 12, and 12 minus 12 is 0. So the question really becomes, like, I kind of was okay. I think we all probably eventually would have found this one. But finding negative 2 is a task. And that leads us then to how we actually solve quadratic equations for the next at least couple of days, maybe 3. And that is we factor. So all of this entire lesson is founded on one simple notion, and it goes like this. This part you absolutely need to write down. This idea, what I'm about to write up here, is at the core of so much of what we do, and it's a very simple principle. It's called the zero product property, and it says that if I have 2 things, I'll just name them A and B, and I multiply them together, and I get an answer of 0. You'll be doing a lot of these in geometry. They're called if-then statements. If this is true, comma, then this has to be true. So if I told you right now that I was thinking of 2 numbers, I'll just call them A and B. And I actually do have 2 numbers in my head right now, and I just multiplied them, and I got an answer of 0. Can you tell me something about my numbers? At least one of them has to be 0. Very good. It's literally the only way to multiply in mathematics and get an answer of 0 is if at least one of your numbers is 0. That's an unavoidable fact, right? So to finish this statement, let's say that if A times B equals 0, then either A equals 0 or B equals 0. You might think, well, that's something that a 4th grader could understand. And I don't disagree, but it is, again, fundamentally at the heart of so much of what we do in algebra and algebra 2 and college algebra and all that stuff. So let's get to it. What we're going to do is we're going to take the left side of the equal sign, because you see how it's set equal to 0. That's not a coincidence. This is important. We're going to take the left side of the equation, and we're going to factor it. This is why we practice factoring before we get to today. So if I said to you, okay, let's pretend this is an assignment or a problem from assignment 20 or 21 or 22, and we were just factoring. I said to you, factor that thing I have underlined in white, what would you do first? You'd build your shells. Does that sound about, is that what you meant? So what we're doing now is we're taking x squared minus 4x minus 12, and we're factoring it down into two things that multiply to make 0. Connection. So what should I put in the beginnings of my shells? X's for sure. What can you tell me about the signs? They have to be opposite. Because of this minus sign right here, that's enough. That's all I need to see. If there's a minus in front of the back number, unavoidably, one of them has got to be positive and one of them has got to be negative, right? And again, assuming you've been doing all of your homework, this is pretty light work for you at this point. Bless you. What numbers are we thinking of? Yeah, for sure. And you had options. You had 1 and 12 and 3 and 4, but you do enough of this. There's a reason I had you practice like 60 of these. You do enough of this and you just start to see the numbers kind of speak to you. And the fact that there's a minus 4 in the middle is nice because a 2 and a 6 are 4 away from each other. So I'm going to stick in a +2 and a -6 because I know that that's the order that they need to go in. Now, think about what we just created. And if you're wondering, like, why did we write down that weird blue thing at the top of the TV? This is why. This is what all of this is founded upon. If I have a factor here, we'll call him the red factor, and a factor here, the green factor, and they multiply to equal 0. You just told me this. What has to be true about my factors? So let's say that maybe it's this one, the red one. What number could you put in place of x to make that factor equal 0? There you go. So one of your answers is -2. It's a whale of a lot more efficient than sitting around and guessing like a monkey, right? And then what makes the green factor equal 0? Very good. Okay. Let's go again. It's set equal to 0. So my training would tell me that I need to start factoring. So I need to take the left side of the equal sign. That's this quadratic trinomial over here, and I need to factor it. Get used to factoring, dudes. What am I going to put in the starts of my shells? What are my signs going to be? Both negatives. Very good. I can tell you guys have been practicing. If they multiply to make a positive, they have to be the same. If the one in the middle is a negative, well, there you go. And what numbers are we thinking of? What multiplies to make 45? That would work. -5 and -9. That will do the trick. I say if you can't factor, then it just really, you're going to feel a real snowball effect today of frustration because all of this is predicated on your ability to factor. What is the solution that we get from the first factor? X would have to equal +5 to make that equal 0. What do we get from this one? Very good. You feeling good so far? Quadratic equations have two solutions. In fact, the fundamental theorem of algebra states that the degree of your polynomial will match the number of solutions. Eventually, you'll be doing cubic functions that have 3 solutions, quartic functions that have 4 solutions, and so on and so forth. Not this year, though. Okay, let's do another. Anything stand out? Good. So if you're still awake and alert following all of this, you need to pay attention. The 18 is a real problem. None of what we're learning today matters if the quadratic is not set equal to 0. So step 1 is always going to be, let's get all of our quadratic stuff together and set it equal to 0, or all of the foundation of what we're talking about is pointless. So if I move the 18, what would my new quadratic say? Good. And now we're pretty much back to where we were before. So we're going to factor because it's set equal to 0. What's going to go in the starts of my shells? Tell me about my signs. One of each. And what numbers are we thinking of? They have to multiply to make 18. So we're definitely thinking of a 3 and a 6. I want to put the 6 on the plus to make it win when I do my little final check. I want the plus 6x to outweigh the minus 3x. And so that's that. What are my solutions then? Good. So I feel like at this point in the lesson, we can graduate from level 1. Those are level 1 problems. That's very, very simple factoring. Leading coefficient of 1 is always simple factoring. So that leads us then to level 2. And in level 2, what's going to change is we're now going to have quadratics that do not have a leading coefficient of 1. Good news, it's already set equal to 0, so that's one task that we don't have to worry about. So let's just dig right in and start factoring. So we build our shells, those empty shells in which our binomial factors will go. What do we know about our starts? Good for you. Tell me about my signs. Positive and a negative. And it really is important now. It's going to be harder sometimes to do these mentally. Just be aware of the fact, embrace the fact that the plus and the minus could very well wind up having to switch places here. The factoring always gets harder when there's a number in front of x squared. Okay. Let's do this. So it's just a game now of just looking for numbers that multiply to make 35. We've already gotten all the signs taken care of. We just got to do our 4th grade times tables. 5 and 7? 5 and 7 are calling out to me. So where are you thinking of putting them? Good. And I appreciate the sense that you're starting to develop. Putting 7 way over here is a smart move. That tells me you've been practicing because this product is big. And so is the number that I'm trying to make. And so we start to understand that we can strategically put numbers in places that'll get us closer to where we want to be. There's nothing wrong with you if you put 7 in the other spot, but the better you get, you start seeing shortcuts. So obviously, the green one makes negative 49x, right? And the blue one makes what? 5x. Of course it would, yes. So that's just all kind of part of this lesson here, is to let you experience that we did a great job of making the number 44. The problem is we made a negative 44. So again, all this practice pays off because now you know that, oh yeah, my signs are not right. Remember, when we get negative and we want positive of the same number, we just switch the signs. Don't you move the 7x, don't move the 7, don't move the 5. Everyone is where they need to be. We just need to change our signs to make the power balance come out correct. We want the minus to make a minus 5x and the plus to make a plus 49. And now the balance is correct. So let's take a look now at then what the solutions are going to be. So let's take a look at the easy one first, the one that I'm underlining up here. What is his answer? Right, that's easy. This one in red, watch out. I find myself still having to explain this to kids 9 weeks into Algebra 2. Man, I can only blame myself. So here it goes. What number makes those parentheses equal 0? Like, if I got rid of that 7, you see how I just vandalized it away like a hoodlum with a can of spray paint? If there were no 7 there, do you guys all agree that the answer would just be x equals 5? Okay, so then the answer is x equals 5. divided by 7. You have to divide by the number that's in front of x. And I'm going to show you this, and I'll show you this periodically whenever you feel like you want me to. But you might say, like, that seems like black magic. Like, why does that work? Well, it works because of this. Remember, what we're trying to do is make this thing that I've circled in yellow, we're trying to make this thing equal 0. Don't ever forget that. That's the goal. And if you say that, like if you write it down, if you say, I need you to equal 0, and I look at that little baby yellow equation, that's like a 6th grade equation. Add 5 to both sides, you get 7x equals 5, divide by 7, and presto. That's how you can always reconstruct, not if, when you forget how to come up with those solutions from the trickier factors, set it equal to 0, and do your thing. Okay, let's go again. Sorry about all the notes today. You'll obviously have a ton of work time. I don't know how much there will be today. Not much, because it's already 8:25, but don't worry. I'm not going to send you home with a big worksheet and demand that you try to get it done. I'm not that guy. First thing you notice, you got to get that 6, Mari. Good. That -6 is got, if that's not your first priority, then any other discussions are moot at this point. So don't worry about the 8. Don't worry about any of that. Let's just worry about getting it equal to 0. So I'm going to bring the 6 across by adding it to both sides. And now I'm happy to have that conversation with you about other things that we notice, like, uh-oh, there's an 8 in front of the x squared. And why does 8 make this problem kind of next level poopy? Because there's multiple factors of 8. Like there's multiple ways for me to make my shells. And so this is sort of next level solving a quadratic, because now we have the annoyance of more difficult factoring coupled with the new content today. So one of the templates could be 8x and 1x, and the other template could be 4x and 2x. Going into this, we certainly don't know which one is correct, but there is one little gift from the math gods, and it's my signs. What are they? They're both negatives, and I like that because I know I won't have to switch those. Like you can't switch a negative and a negative. It's going to be the same. So now the game is, let's just look at all the factors of 6, and there's 1s and 6s and 2s and 3s, and I'm at your disposal. That's not the right word. Your beck and call. You tell me, what do you want me to put in? Sure. Into which template, bro? So you want me to put a 3 and a 2? Sure. And again, it's always going to come down. I cannot believe that people can leave my Algebra 1 class. I'm thinking like I'm the worst teacher in the world. If anyone can walk out of my class and not know that it's all about, I got to say this more, it's all about the blue and the green, man. Sometimes I'll explain that and the kid's like, oh, it's like, man, I've said that 94 times, but sometimes you got to say it 95. It's all about the blue and the green. I hope that they add up to make -19. What does the blue one make? What does the green one make? -6 and -8 make -14. So that's a fail. So let's try something else. What else would you like to try? 6 and 1 in the same template? Sure. Like I said, I mean, I know the answer, but I'm not going to tell you what it is. What's my blue? -12. What's my green? -12 and -4 make. Okay, so that's another fail. What else do you want to try? 3 and 2 on the top. Sure. What's my blue make? Stop that. What's my blue make? -3x. What's my green make? What's -3x and -16x? We did it. And that took us 3 tries. It could have taken us a lot more than 3. 3 is actually pretty good. So that means I don't have to worry about the bottom template anymore. We've definitely established that we found the factors. We know what they are. Now, based on what you've learned already today, let's look at the red guy. What's his answer going to be? 3/8. Very good. And how about my green guy? What's his answer going to be? Good job. Okay. So there's one final push. I have two more examples, probably knock them out in 3 or 5 minutes or so. And so far, I think you're doing great. I hope I'm not reading your body language and your answers incorrectly, but I feel like you're okay. So the final push with this is we're going to get messier quadratics now. So take a look at this. For the record, if we were climbing a mountain today, this is basically the top of the mountain. This is the summit as far as difficulty is concerned. So we learned the zero product property. We learned why we factor. We already know how to factor. This is the final sort of step in the journey. And just what stinks, what reeks about this problem to you? Yeah, there's like terms. And I'm not going anywhere with this until I can get all my parts and pieces onto one side set equal to zero. I don't know if I haven't made that clear, but this is all about the number zero. Make it equal zero. Now you have a decision to make, and you can move all of your terms to the right, or you can move them all to the left. There's a very correct answer, and it's not that I have an affinity for one side over the other, but which side should we move to in this case? Definitely the left, because if I move to the right, then your x squared is going to be negative. And if you're still listening, hear this, hear this, hear this. You always want to put the stuff on the side where x squared will be positive. You don't want to go in and make your life harder by trying to factor a quadratic with a leading coefficient that's negative. Got it? So it's not ever going to be a 50-50, like, I could go, nope, pick the side where x squared will have a positive number. So having said that, if we add this 3x squared across, and we add this 2 across, I feel like we're well past the point in the year where we have to show the little plus 3x squared on both sides, right? If I move the 3x squared, how many will I have? I will. How many x's will I have? Yeah, he doesn't have anyone to go with. What's my constant term going to be? Good. That part has got to go perfect. No little LOL, he forgot to switch the sign when I moved it over the equal sign. That stopped being cute in like the middle of September. So when we move things across the equal sign, we change their signs. And we arrive at this. And this is another pooper scooper because you realize now that there are multiple templates. And so let's get right into it. There's one set of shells. There's another set of shells. And I need multiple sets this time because, again, 6 is not a prime number. Tell me about my signs. Yeah, definitely one of each. And those, so again, that's bad news because we might wind up boo-hoo, like having to switch them, but that's no big deal. Here we go. Here we go. 15. 115, 3, 5. What do you want? In which template? Okay. So technically you have a 1 in 8 shot. I just want to point that out. You have a 1 in 8 shot of guessing this on the first shot because you could do 1, 6, 6, 1, 2, 3, 3, 2. That's 4 possible guesses, but each guess can be made in 2 possible templates. So bear in mind that you have a 12.5% chance of getting it if you just guess blindly. So don't beat yourself up if it takes 3 or 4 guesses. That's just simple odds. But yeah, Bryce got it pretty quick. So if we place the 5 in the 3 where Bryce asked us to, again, it's not about, hey, look at me. Aren't you proud of me? I made 6x squared. Nope, nobody's proud. And like, hey, aren't you proud of me? Look, I made, nope, no one's proud. You don't get gold stars for your 4th and 5th grade basics. Where you earn the master degree is in, does your blue plus your green make negative 13? And it does. What does Bryce's blue make? 5x. And what does Bryce's green make? And last I checked, a 5x and a negative 18x definitely make, which is exactly what we wanted. So having said that, now let me clean up my board a little bit here. We have our factors, not our solutions. We have our factors. And so what answer do we get out of this red factor? Nice job. And what answer do we get out of this green factor? Okay, one more. That's it. Great job. You guys, I think, are doing great. And I am hearing the same three voices over and over again. So as a teacher, we have to be careful. The fact that the same three people keep answering questions doesn't mean the whole class is okay. But I trust by now that you would have spoken up if you're super lost. So like Houston, we have a problem, right? Clearly, we're going to be pulling to the left because 5m squared is like, hey, dudes, I'm positive. Just I'll stay here. Um, how many m's will we have when we're done? Nice, because we're subtracting that 2m across. And what will our constant term be? Yeah. So this should be a significantly simpler problem. To the untrained observer, it looks the same, but someone who's been factoring for a week, you guys know this is significantly simpler because 5 is a prime. So we know we only need one set of shells. And the sign in back is plus, which is always nice because I know I won't have any sign switching to worry about. So because the sign in back is plus and the sign in back is minus, then I know that both my signs are minus. And now 42 is a little poopy, but I'm telling you, you should never start with like 1 and 42 or 2 and 21. You should always start where the numbers are tighter packed. And so what's the tightest packed pair of 42's factors? 7 and 6. Where do you want to put them? 7 in the first one and 6 in the second one. And my blue makes, my green makes -7 and -30 make -37. Jackpot. You guys are pretty efficient factorers, and I appreciate that. So having said that, we've found our factors, but not our solutions. What is my red solution? Good. Positive. And what is my green solution? Do you guys have any questions? Okay, we're going to have about 8 minutes. It's not a lot, I know, but we'll see how many problems we can get done. This will be assignment number 23. And I asked the computer to scramble these. And so they're not going to go warm up, medium, hard. They're going to just whatever. I love that feature that I recently discovered, scramble all questions. So, don't think of it as the first 10 are the easy ones. They're going to be all scattered too.